Yeah, good morning, ma'am. Yes, good morning, ma'am.
Good morning, sir.
Yeah, today we will be seeing about Aneka MapReduce programming. Yeah, this MapReduce program, actually, this one is an implementation by following a reference model introduced by Google and by Hadoop. Google has proposed a reference model for MapReduce, what you call programming model that we have implemented. That is being implemented in Aneka. It will make use of the implementation which is proposed by Google and followed by Hadoop. Okay, so now we'll be seeing earlier classes we have discussed little extent up to little extent regarding MapReduce. Do you remember it? MapReduce programming. Yes, we discussed earlier when we introduced this Aneka. Yes, do you remember it, or can I tell again some example? Okay, let us try to rewind. Yeah, see here, we wanted to perform some particular application execution. Okay, we wanted to perform some task. Let us consider some task we have to perform. Earlier we have considered word count example. If you remember, or you can consider it as independently. Right now, now only we are introducing. Let us consider. Now we have some very big page like A3 page. You know, A4 pages means normal A4 pages. You whatever the white sheets will be using, those are A4 size. A3 means it will be bigger size, maybe some it will be equivalent to at least 4 A4 size pages. Okay, that is A3 size in general. And now let us consider in A3 size we are having a text. Try to follow the example so that entire thing will come under this. I will try to put everything in this particular example so that whenever we go to the concept, just if you remember this example, you can able to write. And that's what. So here you try to understand. We are having an A3 size sheet with the text. Entire text we are having in A3 size. Now you need to count how many words we have, what are the distinct words we have in that particular A3 size sheet, and what is the frequency of those words. Let us say we are having a description about Aneka. How many times Aneka word is present in that particular A3 size sheet? That is that you have to count. And like suppose map reduce is the word. How many times map has occurred? How many times reduce has occurred? How many times task scheduling is there? Task how many times has occurred? Like this, distinct words you have to list and corresponding frequency. This should be the output. Then what should be your approach in general? Is you will be counting, like you will be will process the text sequentially. Then whenever you find a word, immediately you will note down. Like that, you will repeat, keep on repeating. But you are having along with you your friend. You are having your friend along with you. Then you have to utilize his services as well, his or her services as well, in order to accomplish this task in less time. Then what can be your approach in general? Is just you can give half of the page to your friend and half you can take. And the same approach, what you will do, by seeing the count, by seeing the word, you will note down it has occurred one time. It has occurred one time. Like that, for every word, you will write the words and then count one time, like this. It has appeared. Next, let us consider you are having bigger paper, even more than A3. We are having, and not only one friend, you are having several friends with you. Okay, coordinatingly you have to perform, you have to get what are the distinct words and its frequency, their frequency. So now how you will be doing, suppose 5 friends you are having. Yeah, please respond now. If you respond, then it will be very, very interesting. You are having 5 friends with you, and you are having a big sheet, like let us consider one big banner kind of thing you are having. That much size I am saying. That's in that particular one, what are the distinct words you have to list and their frequency. Now how you will do? 5 friends you are having. Yes. Yes, please respond now.
The work will be divided into 5 friends, so we can divide the work into 5 friends equally and then do.
Yes. Yeah, work will be divided into 5 different 5 halves. Let us consider 5 equal parts, like that we can do. That is it. But there is no guarantee that every friend will be that much effective. I'm adding one more constraint, that every friend, every person may not be of equal competence, right? Equal efficiently they could do. So now be done. Yeah. For some particular person, for some particular friend, we can assign more amount of text. For other one, we can assign little amount. For other one, moderately. Like that, we could take decision, isn't it? Such kind of it is practically possible, right? Why? Because we are having several friends. Each will be having their own competency level, so their own efficiency level, we can say. So we will be dividing the text into different parts. Okay, not uniformly we will be distributing. We will be distributing non-uniformly. This is what one constraint. But this is important point to understand. Irrespective of the amount of data, amount of the text that we will be giving to one particular friend, what they have to do. Let us say 5 friends we are having. For one friend we will be giving 20% of the text. For other friend we will be giving 10. For other friend 30% will give. For other friend we will be giving 20. Okay, so there are so many sizes we are having. But irrespective of the text a person has received, we have to perform same kind of operation. What is that operation? They have to see the text they have received, and if they see the word, then they have to count. They have to maintain, like this word has occurred one time. Next, one more word if they see, again they will be noting, and one time it has occurred. Like this, they will be doing the work. So finally, we will be getting the data that words list we will be having, and here constantly one like that will be having. Even though some word like Aneka has occurred several times, for every time there will be an entry Aneka one time. Next, after some time Aneka has occurred again, then Aneka again one time. After some time again Aneka means again Aneka one. Like that we will be having multiple entries for the same word. Okay, this is what each person has to do. So second person also will do same things, third person, like that all 5 friends will do the same processing. Okay, next, is this clear till this point? What what type of output we will be getting from this processing? Yes, is this clear, ma'am?
Yes, sir.
Yes, sir.
Yeah. Now, this particular output will be transferred to, okay, this particular output, let us say we will be storing into files. Okay, we will be storing into files. Each file will contain word and frequency. Word and frequency, in general this frequency is 1 only. Word 1, word 1, like that we will be having the list. Next, what we have to do is we have to consolidate these all, like Aneka has occurred these many times, this task word has occurred these many times, like that we have to give the output. For that, what they have to do is they have to aggregate those all things into one. That is common task for all the friends. Okay, so now what will be the output? Aneka has occurred 15 times. Task has occurred 20 times. A map reduce has occurred 12 times. Like this, we have to give the final output. Now, if you observe both the things, like first, these friends, 5 friends, have done just what are the words and its frequency as 1. Word frequency as 1. This is first task. Another task is same 5 people have aggregated those all. First they have done what are the words and its frequency as 1. After that they have aggregated by taking this one as the input. They have aggregated so that we will be getting what are the distinct words and their frequency. Okay. Now you consider what first work what they have done, that is irrespective of the data distribution, isn't it? First work what they have done is irrespective of the or independent of the data distribution. Like data can be distributed like 10% to one person, 40% to another person, 20% to another person, 30% to another person. Like that, we in any way data can be distributed. Yes or no? Yes.
Yes, sir.
Yeah. Next, second task what they have done is the output of this one they have taken and they have aggregated according to the key. What is the key? That word is nothing but the key. By seeing the key, how many times that key has occurred in the list, that they have aggregated. Based upon that, they have aggregated. So all people have done the same thing, right? So it is nothing but again independent of the data they received, isn't it? So now first task and second task, this we will be saying as mapper. Okay, and this one is reducer. Map logic, reduce logic. So whatever the problem we will be solving, okay, that problem, for that problem we have to give 2 processes. Okay, 2 processes or 2 processing logic we have to provide. First one is mapper logic. Mapper logic in the sense how we have to give is not about how we will be counting and all. Irrespective of the data, how what is the processing they have to do, that we have to provide. Like one text is given, then we have to count distinct words and their frequency, means we will be having several logics. If you provide some logic as a mapper logic, that won't be correct. How we have to give mapper logic is whatever the it may be the data distribution, we should be in a position to apply this common logic among all the mappers. Okay, whatever the friends we have considered, those friends are nothing but processing units, CPUs we can consider. Whatever the friends we have considered, those are processing units. 5 processing units we have. Let us say one what you call one workstation we have, where there exist several cores of a process. Several cores we have. In several core is nothing but CPU kind of thing, right? in one CPU itself, one physical CPU itself, several cores we can have. We discussed in initial classes itself. Core to duo, dual core means 2 processes will be having. Core to duo means so such kind of dual cores 2 will be having, like that 4 cores. Core to duo means 4 cores, like that we will be having several cores within single physical processor. Okay, now if a workstation is having several cores, then by utilizing those all cores simultaneously, we will be using this MapReduce programming. Okay, what is the advantage of doing this one is independent of the data distribution, we could able to perform accomplish the task. Okay, this is what MapReduce. Now we will be having map logic, reducer logic. Logic should be executed independent of the data distribution. Reducer logic should take input as the output of the mapper logic. Okay, output of this mapper should be given as the input for reducer, and this will give the final output. This is what entire MapReduce programming model. Is it clear? Yes.
Yes.
Is it clear, ma? Any doubts so far?
No, sir.
Okay. Let us see now formally how it will be. Some vertical technicalities we will be seeing. Afterwards, I will see the programming, how mapper logic and reducer logic will work. That we will see programmatically. Yeah. Here in this MapReduce programming model, what it will provide is runtime support for developing MapReduce applications on top of Aneka. Earlier in the last class, we have seen task programming model. Task programming model defines support for developing task-based applications, right? Similarly, here MapReduce programming model we have. Earlier to that, we have thread programming model. We have seen, right? So this is MapReduce programming model. In this, here you see, basically we are having some input files. These all are input files, and these will be given to this MapReduce application. Try to understand this carefully. MapReduce application is taking input data files, and then here we are having the logic of mapper and the reducer. Okay, this mapper reducer, then based upon this split logic vertical, this data files will be splitted into several data parts, data portions. Okay, these will be given, and here we are having MapReduce execution service. Several execution services we have. What in addition to MapReduce scheduling service. Earlier task scheduling service we have, task execution services we have. In last class we have seen. Similar to that, here we are having specific to MapReduce execution service and MapReduce scheduling service. Okay, finally from this reducer task, finally we'll be getting the output files. Those output files will be given as the output. So this is the overall story of this MapReduce programming model. Okay, here in this MapReduce scheduling service, which plays the role of master process. Yeah, master process, master worker or master slave we can consider. Master process is nothing but how data has to be distributed, which mapper has to work. These all things will be scheduled by this scheduling service, and it will act as the master service. And these all vertical execution service is nothing but which plays the role of worker process. Just actual processing will be done by these execution services, and there will be a specialized distributed file system to move these files to several execution services. Okay, this is overall idea about Aneka MapReduce infrastructure. And now we will be seeing programming abstractions. If you understand this diagram carefully, if you understand this one clearly, then entire coding will be easier for you. Okay, no need to remember anything. Just I will tell you what to understand. That you, if you understand, then it's fine. See here, programming abstractions. Here we are having IMAP unit. This is the interface. Here itself it is indicated. It is the interface. And whenever we have this kind of symbol, these are fundamentals. You try to understand. If you have completed object-oriented analysis and design or UML kind of subject, then you might have idea already about these kind of diagrams. Have you completed that diagram, subject? Yes or no? Yes, please respond, ma'am. It's Amrita.
Yes, sir.
Object-oriented analysis and design UML diagrams. Have you completed that subject?
No, sir. I don't think.
No. Okay. Okay. Let us see here. IMAP input is the name of the interface, and whenever we have this kind of arrow mark, what does it indicates is it is the base one. From this we are deriving another one. Okay, so here IMAP input is the derived one from this base called IMAP input. That is what we are indicating by using arrow mark. Similarly, here if you understand, mapper base is the base class. Okay, base class, and we are deriving mapper k comma v. Okay, key value. Okay, mapper is another class which we are deriving from the base class called mapper base. Similarly, reducer is the class which we are deriving from reducer base. Did you get the idea about this? Mapper base is one base class from which we are deriving a class called mapper. Similarly, reducer base is the base class and we are deriving reducer class from this. Okay. Now, one last point regarding this diagram that you have to understand here is this mapper k comma v is used to create a class. This mapper k comma v is used to create a class which will act as a mapper. That is, if you extend from mapper, that is, if you derive from mapper k comma v class further, any class, if you derive from this class, then that class will act as the mapper. Similarly, if you extend from reducer, then that class will act as the reducer. That means in our application, we will be having two classes. Okay, one will be deriving from mapper, another one will be deriving from reducer. Okay, those mapper and reducer internally will be deriving from mapper base and reducer base respectively. Got it? Got the hierarchy now? In our implementation, we will be having two classes. We will define two classes. Okay, one class will be deriving from mapper, another class will be deriving from reducer. Okay, those mapper and reducer will be already internally derived from mapper base and reducer base respectively. Got it? I will show you the code. Don't worry. Just if you understand this point, then we will go further. Yes. Yes or no? If you cannot unmute yourself, you please put it in chat box, man. We will be developing two classes. Okay, one will be extending from mapper, another one will be extending from reducer. That's it. These two, if you have understand, if you know, then we'll go further. Here you see IMAP unit is the interface, that is base interface from which we have derived IMAP input. Okay. Now, as we have seen in the last class, iTask, from iTask interface we implemented in one class, from which we have created a task. From that again Aneka task we have created. These things we have seen, right? Similarly, here IMAP unit, IMAP input, mapper base, mapper k comma v. These all things we will be seeing one by one. Yeah. Here you see map function APIs. What we are having here is IMAP unit. IMAP unit input, IMAP input is extending from or implementing IMAP input. See, IMAP input k comma v. It is implementing the interface called IMAP input. That is what indicated here. IMAP input k comma v is extending from IMAP input, this interface. What we are having in this is just the key and the value. Okay, that is input, whatever the key that we will be providing, that we can get, and value we can get. This is basically IMAP input. Next, mapper k comma v. Mapper k comma v should be derived from a base class called mapper base. So mapper k comma v colon mapper base. So it is deriving from mapper base. This is the base class, this is the derived class. In this particular class, we are having a function called map. This is very, very important one. Map is the function name in which we will be writing actual logic of the mapper. Similarly, we will be seeing other methods. Of course, some supporting methods will be having, but as of now, that is not, those methods are not required. The only understanding that you need to have is mapper k comma v class is being derived from the class mapper base, and in this particular class we will be having a method called map. What it is taking as the input is IMAP input object and some emit delegate. In the sense, input will be given and output we will be it will be emitted from this object called emit. Okay, map emit delegate object. Through this it will give the output. The logic we will be writing. Just it is a template kind of thing, so there is no logic included here. But in general, we will be seeing the example with us. That word count example we will be seeing there. You can understand. The point here you have to understand is IMAP input k comma v is deriving from IMAP input interface. Next, mapper k comma v is being derived from mapper base. And in this mapper k comma v class, we are having the method called map, which is taking IMAP input object and giving the map emit delegate object as the output. This is what basically map function APIs. Yeah. Next, now mapper k comma v, that is which we have derived from mapper base class, isn't it? Mapper k comma v we have derived from mapper base class, and we have discussed that in our application we need to have two classes which will be deriving, one will be deriving from mapper k comma v, another one will be deriving from reducer k comma v. So now we will be seeing simple mapper k comma v, that is we will be defining a class which will be extending from mapper k comma v class. So here you see the class name is word counter mapper. This is the class name. Okay, you can take any class name here. This is user defined one, but it has to derive from the class called mapper k comma v. In that, what is k comma v? K is for key, it will represent key type, and v represents value type. So here we have given as a long comma string. String is the value. So now this is the input which we are giving. So we are defining a class called word counter mapper, which is extending from the class called mapper k comma v. That and those k comma v values we have specified. Now in this, as we have extended from mapper class, whatever the map function we have in mapper, that we will be defining here. So here if you see mapper function, map function, okay, what it is taking, IMAP input we are giving as the input, IMAP input object we are giving as the input. So this in this map, what we are doing is whatever the string that we will be getting, okay, that input dot value string, that is the string text that we have in the document, that value we have to get input dot value. So that is nothing but small value. By splitting the value, whatever the text we will be receiving in that particular one, each word we have to split, right? Isn't it? One entire text we will be receiving, each word we have to split. On what basis we will designate one thing as the word is, suppose some two words are separated by space, then we can say each one as a word. Suppose some portions are separated by tab character, then also we can designate both as a words. Suppose from one line to another line we have, okay, like two portions of the text separated by new line, then also we can consider this as one word, this as another word. Similarly, other kinds of what you call delimiters. Suppose one paper is given to you, how many words you have in that particular paper, you have to count. Then what you will do, you will be seeing what are the delimiters. Like space, if you find, then you can count, you can mark it as one word. Suppose exclamatory mark is there, then you will mark it as a word. Suppose what you call parentheses are there, then you can specify that one as the word. Similarly, if tab character is there, more spaces are there, then also you will count it as word. Like that, several delimiters are specified. Based upon these delimiters, we have to split the entire text. This is basically the function that we have, the operation that we will be performing. Value dot split, that is entire text is the value. The text we are splitting into several words, okay, several words based upon these delimiters. What are the delimiters that we are considering are space, slash t, that is tab character, new line character, slash r is for anyone answer? Slash r means, yeah, slash r means you are in final year, you should have more understanding of these all, because these will be important in campus placements. Like whenever you attend for interview, not interview, this written test, then you will be getting questions related to these kind of things. Slash r is for carriage return. Carriage return in the sense, suppose if anyone is interested, I will tell. Yeah, if you are interested, tell me.
Yes, sir.
Yeah, okay, fine. See, suppose if you write IFHE in printf, plus IFHE, that's it. Within double quotes, if you write IFHE will be printed. Suppose after IF, if you put slash n, then HE, then how it will be the output? IF will be printed in one line, HE will be printed in next line. This until this point, you know. Now, if I specify IF, then slash R, IF slash R, then HE, then what will be the output? This will be the question in your written test. Got my question?
Yes, sir.
Yeah. So what will be the output? Okay, I will tell you the answer, and again I will ask another question. Try to guess what can be the functionality of it. What you call the output will be HE, not IF. Okay, the input is IF slash or HE. Now output will be HE only. Okay, now I will give you another variant of it. Welcome to IFHE is the string. Okay, after welcome to slash r, then IFHE is given. Then what will be the output?
IFH.
IFHE.
IFHE. Okay, this is something you are trying to guess from the earlier input output combination, right? Yeah. Now I will give you the answer. Now you try to understand the functionality. Answer will be IFHE. Okay, IFHE, then OME space 2. I'll type if you want in the chat box. I'll type IFHE OME space 2. This will be the output. Now you try to guess.
2.
No. What is the functionality I'm asking? This is the output of the given what you call second question I have given, right? That second question answer is this. Now what can be the functionality of slash r?
It is again starting from the 4 characters at the beginning.
Starting from the
See, I mean, it is skipping the first 4 characters.
it is skipping the first
Then-
4 characters. That means slash r
Mhm.
means whatever the it will be printing, right? What you call welcome to, like that. It will print in general. First it will print. Afterwards, after seeing that slash r character, that cursor, that blinking cursor will be there. That cursor will be placed to the beginning of the line. Okay, in that printed line, to the beginning of the line, that cursor will be placed. So at W will be having the cursor. Now what it has to print? IFHE, right? So I will be printed there. That means W will be overridden with the character I. E will be overridden by F. Like that, IFHE will be printed. Then remaining characters it won't touch. It's those characters already printed, right? That's why the output will be IFHE OME 2. Got it?
Yes, sir.
Yeah, that is the functionality of slash r. This is a frequently asked question in written test. Try to explore something out of this. Slash r means carriage return. Just it will place the cursor in the at the beginning of the current line. That is what it will do. In general, how they will ask is they will club this with slash t or slash n kind of thing. Like they will print something and they will put slash r and some other text they will put. Then they will try to frame the what you call characters in such a way that after printing this one from the beginning, it will form some meaningful word. Okay, that's what they will surprisingly give. And just if you understand this functionality, then you can answer easily. Okay, yeah. So here you see slash t, slash n, slash r, slash f. Slash f is for form feed actually. Nowadays they are we cannot observe the functionality of it. Just if you try to print slash f, then some actor kind of thing will be printed. Actor in the sense, suppose while drawing you have to mention one human is there. Then how you will draw? Just you will put actor, right? That actor kind of a symbol you will be getting if you use slash f. So other delimiters are slash double quotes means double quotes will be considered. Slash single quotes means single quotes will be considered. If you don't use slash, what will happen? It will consider as end of the string, end of this double quotes here itself. But we are ending this double quotes here. Got my point? Why we are using slash here is, if you use double quotes alone, it will map with the corresponding double quotes opened earlier. But what we wanted to indicate is Double quotes also you have to consider as delimiter. Single quotes also you have to consider as delimiter. That's why we are using slash and exclamatory mark, hyphen, equal to. All these we can consider as delimiter for a word. So like that we will be dividing. After that we are giving the count here for each word, comma 1. As we have discussed earlier, word comma 1. That means Aneka has occurred one time. Task has occurred one time. Aneka has occurred one time again. Like that, entire list will be given or will be emitted as the output. This is what mapper logic. Is it clear till this point? Yes.
Yes, sir.
Yes, sir.
Yeah. Now, same similar to the map function APIs which we have seen earlier, here we are having reduce function APIs. In this, if you observe, there is a class called reducer k comma v. What we are from what we are deriving reducer base. Reducer k comma v deriving from reducer base, and as we have map method earlier, here we are having reduce. Reduce is the method. These two lines, if you understand, then it's fine. Just similar to mapper. Here, that enumerator which we have got from earlier input output, okay, earlier output, that is mapper output, that will be given as the input for this reducer, and it will give the output as reduce emit delegate object. Okay, this is a base thing. Next, whenever we wanted to write reducer logic, we have to derive from which class? Reducer k comma v. That is, in our application we need to define two classes, right? One class has to derive from mapper k comma v, another class has to derive from reducer k comma v. So mapper reducer a class deriving from mapper k comma v, we have seen already, that word count mapper. Now we will be seeing reducer k comma v. So this word count reducer has to derive from which class? Reducer k comma v. And in this we have to overwrite a method called reduce. Reduce is the method. In this reduce method, just we will be taking the input which we have got from mapper, and we will be taking one by one. Once if you take one word and its count, then what we will do is will be repeating whether it is having same kind of word again. Then we will sum up those all, so that we will be getting the actual count of one particular word. Got it? So Aneka, how many times it has occurred. So until we have got null, it will be repeated, and we will be summing all this. This is the functionality of reduce. For every word, there will be a different reducer. Finally, we will be getting this sum for each and every word. This is reducer logic. Is it clear, ma'am? Similar to map logic, we are having reducer logic. Yes?
Yes, sir.
Yeah. Next, and now we have defined two classes. One is word count mapper, another one is word counter reducer. These two will act as reducer and mapper and reducer for our application. Now we will be seeing map reduce application m comma r. In this map reduce application, what we have to do is just we have to derive from a class called application base. Actually, this is also present in that earlier diagram that I will show you. Yeah, in this diagram you can see that also. Map reduce application m comma r. This how we are creating is we are deriving from map reduce base. Yeah, map reduce application we are creating, and we are deriving from application base. Okay, here m is the map reduce dot mapper base, r is the reducer base. M comma r, m is the mapper base, r is the reducer base, and several functions we have in this. that is how many partitions it has to do, how many times, suppose one particular CPU has failed to execute a task, then how many times we have to retry. These all things are mentioned here. Like 3 times we have to see until we conclude that task has failed. We have to retry for 3 times by default. Similarly, how many partitions is by default? 10 partitions. Like this, several constants we have defined in this particular one. This is internally available one. Okay, try to understand. These all are internally available ones, like which we have seen with respect to mapper k comma v, reducer k comma v. Those all classes already defined. What is our task is, in our application we need to define 2 classes. One is to derive from mapper k comma v, another one is to derive from reducer k comma v. Like that, this class is also defined in the library as already. That is, in APIs it's already defined, and whatever the constants we have in this particular one, those only mentioned here. You see, partitions by default 10 partitions it will do. If you wanted to alter, then we can alter it. Attempts means this property contains number of times the runtime will try to execute a task before declaring it failed. Before declaring it has failed, it will try to retry for 3 times. Use combiner. That means whether MapReduce runtime should add a combiner phase to the map task execution in order to reduce the number of intermediate files. That means before giving to the reducer, whether it has to the output has to be combined intermediately or not. Then by default it will be set to true, so that the number of output files that it will generate will be reduced. That is what the advantage of this use combiner parameter. Similarly, sync reduce. This property stores information that whether all the reducer has to work in synchronous to each other or not. By default, the value is set to true. That is, all the reducer has to synchronize themselves. Is input ready? Whether the input files, like indicating whether the input files are already stored into the distributed file system or not. If not, then we have to upload from client manager before executing the job. By default, the value is set to false. That indicates we have to upload from the client manager. This is what, like this, we are having several parameters. If you read, then you can understand easily. But these parameters will be controlled by the Aneka, what's called MapReduce application. Okay, and finally, I will show you one important thing. Just 3-4 minutes I'll take. Finally, we have to submit a job to the Aneka. Okay, MapReduce job we have to submit. How that job will be built, that we will see. See here, word counter job. This is this will give you overall story. This will consolidate overall story. See here, there is a program in this in which we have actual main function. In this main function, earlier we have considered this main function in threads in task programming. Now in MapReduce also we are having main function. In this main function, we will be creating an object for MapReduce application. MapReduce application we are instantiating here. How we are instantiating is by calling the constructor. MapReduce application is the class name, so we are calling the constructor associated with this by providing some configuration objects and all. And what is the mapper? Word count mapper, which we have created earlier. What is the reducer? Word count reducer, which we have created earlier. So these two we have created, that you know already. Okay, now we have created an object for MapReduce application. What is the name of the object? Application. So this object we have to use in order to start our MapReduce work. Okay, that is the execution of application. We have to start by using this particular object. So application dot invoke and wait. This is the function that we are invoking in order to start our application. So we are creating an object for map reduce application by providing what is the mapper, what is the reducer, and by using this application object, we are invoking a method called invoke and wait. Okay, invoke and wait, so that this application will start its execution. This is basically map reduce job. Okay, remaining all are like comments only. Just you have to understand here, we have to create a word count mapper, which has to be derived from mapper k comma v, which has to be derived from mapper. Similarly, word count mapper we have to create which has to be derived from reducer k comma v. Internally, that reducer k comma v has to be derived from reducer. So in this word count mapper, we will be having a method called map. In reducer, word count reducer, will be having a method called reduce, where we will be writing actual processing logic. Is it clear? Yes.
Yes, sir.
Yeah. So this is about map reduce programming using Aneka. I don't think try, catch, finally these things I need to explain, because these are all part of Java actually. If you want, in 1 minute I will try to tell. If you, do you want it? Try, catch, finally. In interviews also they will be asking these questions. Exception handling. Try, catch, finally. If anyone wants, I will tell in 1 minute. Do you want it or not? You please respond. Otherwise, stop.
Explain it, sir.
Yes, sir.
Okay. See here. It is like suppose you are having a code where we are having some statements which are exception prone, like on roads will be having accident prone areas, right? There we will be more careful, right? Similar to that, we will be having exception prone areas. Those instructions we will embed within try block. Try block in the sense whatever the statements under closed open curly brace and closed curly brace, whatever the statements we will be having, that you can consider as a block. Okay, on top of it, if you write try, then open curly brace, closed curly brace, then that is exception prone block of code. Is it clear? Try block. Next, catch block. If exception has occurred in this try block, that has to be that can be caught by this catch block. So what has to be done? Suppose accident has happened, then how further things have to be taken care? That is being written in catch block. If exception has occurred in this try block, then what has to be done? That is, we will intimate to the user, or we will call another function, or we will change the parameter and re-invoke the same thing, or some parameters will be some strategy we will be having. That strategy we will write in catch block. Okay, this I think until this point you have idea. The point here is finally block. Finally block in the sense, suppose you went to ATM card, ATM machine. You went to ATM machine and you have inserted your ATM card. After that, it will ask enter your PIN, enter amount, whether a savings bank or current account, savings bank account or current like this. They will be asking several questions. Finally, let us say whatever the amount you have entered, let us say 10,000 is the balance that you have in your account, and you have entered 11,000 to withdraw. Okay, although you have entered correct PIN, savings bank correctly, you have chosen everything, you have chosen correctly, but the amount you have entered is 11,000. Then what it will do, as you have entered correct PIN, it will open your file to see what is your file, in the sense your account it will open, and it will see what is the amount that you have. Okay, if you have 10,000, 11,000 or 12,000, then whether it is allowed to give 11,000 which you have requested or not, it will find, and accordingly it will dispense the cash. But if you have less than it, then what will happen? How it will come to know? By opening your file only, it will come to know how much amount you have. Okay, how it can open? By validating your PIN, then only it can open. So your file is open. Okay, your file is open. Now it will see your your available balance. Then it will try to come to know that you are not allowed to withdraw that much amount. Then that message will be given. Okay, that message will be given to you. Then your ATM card will be sent back. This is what will be happen. But whatever the file you have opened, okay, that means your file has opened by ATM machine. That file has to be closed properly, isn't it? That file has to be closed properly, so that no other vulnerabilities takes place. Okay, in general, how it will be done is, if normal flow, like you will be entering the PIN number, then amount, then it will open the file which you have intended for you, and it will see the what you call balance. Accordingly, whatever they, suppose 5,000 you have entered, from 10,000, 5,000 will be deducted, and remaining balance will be updated in the file. Then it will be closed. Then 5,000 will be dispensed. What you call, the cash will be dispensed to you. This is what normal process. But if an exception has occurred, what is the exception condition here? You don't have proper balance in your account, which you have you are trying to withdraw. Then exception has occurred. Then also the file has to be closed, isn't it? Even though you have not performed anything in this, that file has to be opened. That file has to be closed properly. Yes or no? Yes, please respond, ma'am.
Yes, sir.
Yeah. Then that particular code we will include in a block called finally. Now I will try to generalize this functionality in such a way that whatever the mandatory functionality that we have to perform, that logic we will include in finally block. Okay, that means even though what you call valid transaction has performed, we have to perform closing of the file. If some exception has occurred, then also we have to perform closing of the file. Such kind of mandatory code we will include in the finally block. If you write as a normal try block, if exception has occurred, then remaining code will not be executed. Let us say 10 statements we have in try block. After 5 statements, we have written that closing of a file and all. If exception has occurred at 5th statement, then remaining 5 will not be executed. Let us say if you write it in catch block, same closing of the file, if you write it in catch block, what will happen? Whenever exception has occurred, then only it will execute. If no exception has occurred, then it won't execute. Got my point? If exception has occurred, then if you write it in try block, it won't be executed. If you write it in catch block, only when exception has occurred, then only that file will be closed. If not in normal flow, it will not close. That's why we will be having a provision that whatever the mandatory code that we have to perform, that we will be include, that we will embed in finally block. Just finally, then close, open curly brace, closed curly brace. Within that, whatever the mandatory code, irrespective of exception has occurred or not, that we will put in finally block, so that it will execute always. That is what the functionality of catch, what you call try, catch, finally. Is it clear?
Yes, sir.
Yeah. Yeah. Thank you, ma. And you have this test